When we dream of leaving Earth, our eyes almost always turn to the red planet. Mars has dominated our science fiction and our scientific ambitions for decades, a seemingly perfect second home. But what if there's a better option? A world far more distant, yet surprisingly more hospitable in some ways. I'm talking about Titan, Saturn's largest moon, a place shrouded in a thick orange haze. Today, we're going on an interstellar real estate tour, comparing two of the most tantalizing destinations in our solar system. We'll weigh the pros and cons of building a human colony on Mars versus Titan, and the answer might surprise you. Let's start with Mars, the familiar neighbor. Its biggest selling point is proximity. A trip to Mars takes about 6 to 9 months, a long journey, but manageable with current and near-future technology. This closeness means faster communication, with a delay of only about 3 to 22 minutes, depending on our planet's positions. For early colonies needing urgent support from Earth, this is a massive advantage. Mars also offers a solid surface to build on, something we take for granted but is a luxury in the outer solar system. We can land spacecraft, deploy rovers, and construct habitats directly on its rusty regolith. Furthermore, we know there's water on Mars, frozen in its polar ice caps and likely buried underground. This is crucial not just for drinking, but for creating breathable air by splitting water into hydrogen and oxygen, and for manufacturing rocket fuel. The Martian day, or sol, is also remarkably similar to Earth's, lasting just under 25 hours. This familiar day-night cycle would make it easier for human circadian rhythms to adapt, a small but significant psychological and physiological benefit. However, Mars is far from a paradise. Its atmosphere is incredibly thin, less than 1% the density of Earth's. This thin veil offers almost no protection from the harsh radiation that bombards the solar system. Cosmic rays and solar flares would be a constant lethal threat to any colonists on the surface. Living on Mars would mean living underground or inside heavily shielded habitats, with limited time spent outside, even in advanced spacesuits. Then there's the dust. Martian dust is fine, abrasive, and toxic, containing perchlorates. It would get into everything, damaging equipment and posing a serious health risk to anyone who inhales it. The temperature on Mars is also brutal. While it can reach a balmy 20 degrees Celsius at the equator on a summer day, the average temperature is a chilling minus 60 degrees Celsius, plunging much lower at the poles and at night. So, while Mars is close and has solid ground, it's a world that requires us to live in a sealed, shielded box, constantly fighting against radiation, killer dust, and extreme cold. Now, let's journey much farther out, past the asteroid belt, past Jupiter, to the realm of Saturn. Welcome to Titan. From a distance, it looks like a serene orange orb, but it's one of the most Earth-like worlds we've ever discovered. And when I say Earth-like, I mean it in some very specific and astonishing ways. Titan's single greatest advantage is its atmosphere. It is the only moon in our solar system with a substantial atmosphere, and it's even denser than Earth's, about 1.5 times the pressure at the surface. This thick, nitrogen-rich atmosphere is a game-changer. It provides a natural shield against cosmic radiation and micrometeoroids, something Mars completely lacks. Colonists on Titan could walk on the surface without needing a heavily pressurized suit or worrying about being fried by a solar flare. Of course, they'd still need protection from the cold and an oxygen supply, but the suit required would be more like an extreme cold weather scuba suit than the bulky, pressurized armor needed for Mars or the Moon. This dramatically simplifies surface operations. The surface pressure is so comfortable that you could theoretically stand on Titan with just an oxygen mask and very, very warm clothing. Your body wouldn't need a pressurized suit to keep your insides from boiling, a problem you'd face on Mars without one. But what about resources? This is where Titan truly shines in its own unique way. The surface of Titan is covered in liquid, not water, but liquid methane and ethane. There are rivers, lakes, and even vast seas of the stuff. These liquid hydrocarbons are an incredible energy source. A colony on Titan would have a virtually unlimited supply of fuel right on its doorstep. We could power our habitats, vehicles, and industries for centuries using the very ground we walk on. Scientific research from the Cassini-Huygens mission confirmed the presence of these vast liquid bodies, like Kraken Mare and Lausier Mare, larger than any of the Great Lakes on Earth. This isn't science fiction. It's a proven reality. Underneath Titan's icy crust, scientists strongly believe there is a massive ocean of liquid water. If we could access it, perhaps through drilling, we would have the two key ingredients for life as we know it: water and complex organic molecules, which are abundant on Titan's surface. The sheer abundance of organic materials, the building blocks of life, makes Titan a scientific wonderland. The potential for discovering new forms of chemistry, or even life itself, is immense. Of course, Titan has its own set of extreme challenges. Its distance is the most obvious one. A journey to Titan would take years, possibly 7 or more, making resupply missions and communication incredibly difficult. The communication delay would be hours long, meaning any colony would need to be almost completely self-sufficient from day one. There's no calling Earth for a quick fix if something goes wrong. And then there's the cold. Titan is unfathomably cold. The surface temperature hovers around a steady minus 179 degrees Celsius. This is far colder than the most extreme temperatures ever recorded on Earth. This extreme cold makes a lot of materials we rely on brittle and useless. We would need to develop entirely new technologies and materials capable of functioning in such a cryogenic environment. However, the cold is consistent. Unlike Mars, with its wild temperature swings, Titan's thick atmosphere keeps the temperature stable, making engineering for the environment a more predictable challenge. So how do we build? On Mars, we'd likely use the regolith to 3D print structures. On Titan, we could use the abundant water ice as a building material. Water ice at Titan's temperatures is as hard as rock and could be used to construct incredibly strong and stable habitats. Imagine bases carved directly out of ice or built from ice blocks, using the very landscape as our construction yard. The energy from the liquid methane could be used to melt the ice for processing, and then allow it to refreeze into desired shapes. Let's do a direct comparison. Radiation protection? Titan wins, hands down. Its atmosphere is a natural shield Mars can only dream of. Energy resources? Titan wins again. Mars has sunlight, which is weak at its distance, and potential for nuclear power. Titan has literal seas of fuel. Proximity and communication? Mars is the clear winner. Its closeness to Earth makes the initial stages of colonization vastly more feasible. Surface conditions? It's a trade-off. Mars has a more manageable temperature range, but a lethal radiation environment and toxic dust. Titan is cryogenically cold, but has low gravity and a protective low-pressure atmosphere that makes surface work easier. Ultimately, the choice between Mars and Titan is a choice between two different types of challenges. Mars is a challenge of shielding and life support in a vacuum. Titan is a challenge of distance and extreme cold. Building a base on Mars feels like a logical next step, an extension of our lunar ambitions. It's a difficult but understandable engineering problem. Building a base on Titan, however, feels like a leap into a truly new frontier. It would force us to develop revolutionary technologies for energy, materials, and long-duration spaceflight. Perhaps the answer isn't either, but both in time. Mars could be our first step, our training ground for becoming a multi-planetary species. It's where we learn to live off-world, to handle the psychological and physical strains of being away from Earth. It's the outpost from which we might one day launch even more ambitious missions. Titan represents the next level, a destination that promises not just survival, but long-term sustainability with its abundant resources. A colony on Titan wouldn't just be a remote outpost. It could become a powerful, self-sufficient hub of the outer solar system. So while the red planet captures our current imagination, don't forget the hazy orange moon of Saturn. It's a world of liquid seas, organic dunes, and a thick atmosphere, holding secrets and resources that could one day power the future of humanity. The ultimate space colony might not be where we think. What are your thoughts on this interstellar debate? Let us know in the comments below. And for more deep dives into the cosmos, make sure you subscribe to Space Repo.